In this video, we will demonstrate how to configure HTTPS for DX NetOps Virtual Network Assurance, often referred to as VNA. VNA is one of the application components that make up the DX NetOps platform. As a part of the platform, VNA is responsible for collecting performance data from SDN technologies. This data is shared with DX NetOps Performance Management and DX NetOps Spectrum. The data is then aggregated with performance data from other sources and displayed in the DX NetOps portal. When HTTPS is enabled for VNA, the connections between the various other DX NetOps components are secured. To understand what is secured using VNA, let's take a look at the architecture. VNA is a Java application that runs on a Wildfly application server, formerly known as JBoss. The VNA Wildfly application server is hosted on a server running on Linux. To collect SDN performance data, VNA uses a plugin to connect to the SDN controller and collect performance data from the controller. VNA provides a unique plugin for each SDN vendor supported by VNA. The SDN inventories can be large, so to avoid performance issues, it is a best practice to deploy a VNA server for each SDN technology in the environment. And because many organizations utilize multiple SDN technologies in their environments, it is common to have multiple VNA servers deployed. In the DX NetOps platform, VNA data is integrated with data from other sources. To share the SDN data, VNA acts as a publisher for the data, and the other components in the DX NetOps platform that receive the SDN data from VNA act as subscribers to the data. For example, to send data to performance management, a VNA server is connected to a data collector, and VNA sends SDN data to the data collector, where the data is then aggregated into the performance management data. In this scenario, VNA acts as the publisher of the SDN data, and the data collector acts as the subscriber of the SDN data. When HTTPS is configured for VNA, the connections are secured between each VNA server and each of the subscribers to the data. Also, VNA uses the DX Virtual Network Assurance API console, sometimes referred to as the Swagger UI, for VNA system configurations. The API is installed with VNA, and the API is accessed from a web browser client. When HTTPS is configured, the connection between the VNA server and the browser connecting to the API is also secured. So collectively, it is the connections from each VNA server to the subscribers, and the connection to the DX Virtual Network Assurance API, that are secured using HTTPS. And by securing VNA with HTTPS, this helps reduce the risk of attacks, such as man-in-the-middle attacks. Also, it is good to know that each VNA server has a MySQL database installed on the same host. But because MySQL is on the same host server as VNA, this connection is typically not secured. However, if you need the connection to MySQL secured, contact the DX NetOps support team, and they can help you configure this connection. Now, let's take a look at the HTTPS concepts that you will need to understand to configure VNA. To secure the VNA connections, a certificate chain and encryption keys are used. The certificate chain is made up of a root certificate, an intermediate certificate, and a server certificate. The root certificate signs the intermediate certificate validates the server certificate, and the server certificate identifies the server to other components. This workflow creates a chain of trust between the root, intermediate, and server certificates. The encryption keys consist of a private key and a public key. The private key is used for decrypting communication data, as well as creating digital signatures, and the public key is used for encrypting communication data and verifying digital signatures. The certificates and keys are stored in a trust store and a key store in the Wildfly system. To ensure that the other DX NetOps components will immediately trust the VNA servers are configured using certificates, created and signed by a certificate authority, often referred to as a CA. Certificates issued by a CA are called CA-signed certificates. In this video, we will demonstrate two ways to acquire CA-signed certificates. The first is to send a request to CA to generate and sign a private key. Then from that private key, generate and sign the certificate chain, consisting of the root, intermediate, and server certificates. When the CA returns the private key, and the root, intermediate, and server certificates, they are imported into the VNA stores. The second way to acquire CA-signed certificates is for an organization to generate their own private key, then use the private key to create a certificate signing request, known as a CSR. The CSR contains the private key generated by the organization, and the CSR is sent to a CA to request CA signed certificates. When the CA receives the CSR, the CA uses the private key generated by the organization to create and sign the certificate chain, and the chain is returned to the organization. In this scenario, when an organization generates a private key, the tool used to generate the private key also creates and signs a certificate chain which is imported into VNA. Because the organization generated the private key themselves, and the certificates were signed by this private key created by the organization themselves, the certificates are referred to as self-signed certificates. In this scenario, VNA is secured with HTTPS using the self-signed certificates. However, it is not recommended to use self-signed certificates due to the fact that most servers, browsers, and operating systems will not immediately trust a self-signed certificate. And this lack of trust can cause communication issues with the VNA subscribers. To fix this, the CA signed certificates returned by the CA are imported into the VNA stores, replacing the self-signed certificates with CA signed certificates. Once the CA signed certificates are imported, other components will immediately trust the certificates. Next, we'll go over the tools used to configure HTTPS for VNA. There are two tools VNA uses to configure HTTPS. One is the Configure SSL VNA script, and the other is the KeyTool utility. These tools import the certificates and keys, place them in the appropriate trust stores and key stores, and update the configuration files to use HTTPS. The tools import the certificates using the privacy-enhanced email format, with the extension .pem, referred to as a PEM file. To receive the certificates in the PEM format, when a request is sent to a CA, the request includes instructions to return the files in the PEM format. When a PEM format is requested, the CA will often return a single PEM file that contains the private key, if requested, and the certificate chain. To import the files, the private key and the certificates are broken out from the single PEM file, and saved off as individual files. The private key file is saved as private.key. And the certificate files are saved as root.pem, intermediate.pem, and server.pem. With all of this in mind, we will begin the demonstrations by first, backing up key system files. From there, we will then demonstrate how to configure HTTPS for VNA by requesting a private key and certificates from a CA. Then, we will demonstrate how to generate a private key and create a CSR from the private key. We will perform the demonstrations using the command line, and logged in as the root user. In the demos, we will use files provided by an actual CA, but we will not cover the process of submitting a request through a CA site, as each CA can have a different request process. It is also important to note that the steps in this video will need to be repeated on each VNA server in your environment, to ensure all the VNA components in the DX NetOps environment are secured. To get started with the demonstrations, the first step is to back up VNA system files that are modified when HTTPS is configured. The first file we will back up is the Wildfly standalone.xml file. When the Configure SSL VNA script runs, the script updates the file to use HTTPS instead of HTTP. The standalone.xml file is located in the VNA install directory under Wildfly, standalone, configuration. We just want this file available during the configuration process, so we will use the temp directory as our backup folder, and copy the file to the temp directory. We will search the same directory for the Wildfly keystore.jks file. The keystore file is a bit different though. We want to verify the keystore file does not exist because when the Configure SSL VNA script runs, it creates a keystore in this directory, and if a keystore file already exists, the script will fail. We'll search the configuration directory for the keystore.jks file, and we can see the file does not exist, which is what we want. If a keystore file did exist, we would make a backup copy of the file in the temp directory where the standalone XML file was backed up to, then delete the keystore file in the configuration directory. Now we'll back up the last file, which is the Java CA certs file. The CA certs file contains the CA signed certificates, and is located in the Java installation directory under lib, security. We will create a backup of the CA certs file, but this time, instead of copying the file to the temp directory, we'll create a copy of the file in the same directory as the original CA certs file, and we'll add .org to the end of the file, marking this as the original file. By creating a backup in this directory, we have the file in an easy-to-find location in case we need to revert back at a later time. So with the files backed up, we can start the HTTPS configuration demonstrations. We will first demonstrate how to perform the HTTPS configuration from a fresh install on a new server where HTTPS has not been configured at any time. In this scenario, we have requested a private key and a certificate chain from a CA in the PEM file format. The CA returned a single PEM file with the hostname of the VNA server as the file name. The tools used to configure HTTPS for VNA cannot parse the PEM file and extract the certificates and the key, so the PEM file needs to be opened, and the encrypted text for the certificates and the key copied to individual text files. The certificates are saved with the .pem extension, and the private key is saved with the .key extension. We'll open the PEM file that is stored in the temp directory. Open the PEM file with the VI editor, but any text editor can be used for this process. In the PEM file, the encrypted text for the private key and certificates is contained within begin and end statements. To create the individual files, the encrypted text is copied, including the complete begin and end statements, then pasted into each individual file. For the sake of time, we will go through the PEM file and explain how to identify the correct text to copy and paste for each file, but we won't actually demonstrate creating the individual files. We'll start with the private key. The private key encrypted text is clearly defined in the private key begin and end statements. To create the private key file, copy the encrypted text, including the private key begin and end statements, paste the text into a text file, and save the file as private.key. Next we'll look at the certificates. Unlike the private key, the certificates are not clearly identified in the begin and end statements, so we need to look at the subject and issuer fields to determine which certificate is which. The subject field identifies the type of certificate, and the issuer field identifies the issuer, or the entity that signed the certificate. For the root certificate, the subject field has the word root in it, making it easy to identify. To create the root certificate, copy the encrypted text, including the complete begin and end statements, paste the text into a text file, and name the file root.pem. For the intermediate certificate, the word intermediate is included in the subject, clearly indicating this is the encrypted text for the intermediate certificate. Also, as a note, the issuer is the root certificate, and since the root certificate signs the intermediate certificate, this also indicates this section contains the text for the intermediate certificate. To create the intermediate certificate, copy the encrypted text, including the complete begin and end statements, paste the text into a text file, and name the file intermediate.pem. For the server certificate, the word server is not in the subject field. Instead, the hostname for the server is in the subject, indicating this is the encrypted text for the server certificate. Also, the issuer is the intermediate certificate, and since the intermediate certificate signs the server certificate, this also indicates this section contains the text for the server certificate. To create the server certificate, copy the encrypted text, including the complete begin and end statements, paste the text into a text file, and name the file server.pem. To save time, we made the files off-screen, and we can see we now have the private key, root PEM, intermediate PEM, and server PEM files all broken out and stored in the temp directory. We can now import these files with the HTTPS tools. And keep in mind, these files are critical to the security of the system, so once the HTTPS configuration is done, the private key and certificates should be moved to a secured backup location, and the files permanently deleted from the temp directory. Next, we will begin the HTTPS configuration process by running the configure SSL VNA script. Keep in mind, this demonstration is on a system that has never been configured for HTTPS, so the first task is to run the configure SSL VNA script. The script will create the Wildfly key store, and then import the private key and the server certificate we created earlier from the PEM file. And remember from earlier, the script will fail if a key store exists, which is why we verified a key store did not exist before beginning the process. After we run the script, we will use the keytool utility to import the root and intermediate certificates, completing the configuration. To get started, the configure SSL VNA script is located in the VNA install directory, in the tools bin directory. We need to execute the script from this directory, so we will navigate to the directory first. To run the script, we need to use the password flag, and we'll enter the default password, change it. We'll run the script, and right away, we can see the script has created the key store in Wildfly, and is ready to import a certificate. At this point in the script, if a key store already exists in the Wildfly directory, the script will fail, and the key store will have to be deleted before running the script again. For this demo, we will import a CA signed certificate, so we'll enter option 2. The next prompt is where we import the server certificate we have stored in the temp directory. We'll enter the path to the certificate and the file name for the certificate. Then after importing the certificate, we'll import the private key, which is also in the temp directory. We'll enter the path to the key file and the file name for the key file. Next, we'll enter the alias name for the certificate. The default is CA-VNA, but in an environment with multiple VNA hosts, the alias can be more descriptive to identify the host key. For example, if this VNA server hosted the Viptela plugin, the alias could be VNA Viptela. For this demonstration, we'll hit enter to accept the default CA-VNA alias. And then we can see the PKCS12 key store is being created, and the key store is being imported in the Java key store. After the key store creation is done, we need to select the TLS mode. We'll enter 1 for mixed mode, which is also the default, so we could also just press enter. The mixed mode is the most flexible mode, but this can be changed later if needed without having to re-import or update certificates or keys. If you are unsure which mode to select, check with your security team. At this phase, the script provides a note about TLS protocols and securing the communications between the VNA Wildfly application and the VNA MySQL database. These two components are hosted on the same server, so in most cases, this connection does not need secured. But, if your organization requires securing connections between the components on the same host, reach out to support for assistance with this configuration. So for the prompt asking if we would like to configure server certificate validation for the MySQL server, we will enter 1 to keep the MySQL secure communications disabled, and the script performs the final tasks. Then, once Wildfly restarts, an info message displays, indicating that the configuration for VNA was successful. What is important to note here is that the configure SSL VNA script can only be run once, since this script creates a key store, and if a key store exists, the script stops running. So because there is a key store in place now, the script will not run again unless the key store is deleted. With this in mind, to import the root and intermediate certificates, we will use the Java key tool installed with VNA. We'll configure the key tool utility to import the root certificate first. In the key tool command, the import cert flag indicates the tool will be used to import a certificate. The trust CA certs flag tells the utility that the certificate is from a CA and can be trusted. The key store flag is the full path to the Java CA certs trust store, located in the Java install directory, under the lib security folder. The store pass flag defines the password for the key store, and will use the default password of change it. The alias flag defines the alias for the certificate to import. When the CA created the root certificate, it gave the certificate the alias of root CA, so we will enter that for the alias. And for the file flag, we'll enter the path and file name to the root certificate for the key tool to import. We'll run the key tool utility, and at the prompt asking if we trust this certificate, we'll enter yes. And now we can see the certificate was added to the key store. For the last configuration step, we need to use the key store tool to import the intermediate certificate. We'll use the same flags that we used to import the root certificate, but for the alias, we'll enter intermediate CA, and for the file, we'll enter the path and file name for the intermediate file. We'll run the key tool utility, and we can see the process is finished, and the message indicating the certificate was added to the key store. VNA is now configured to communicate with HTTPS. To test the HTTPS configuration, we'll access the DX Virtual Network Assurance API. When HTTPS is enabled, the URL used to access the DX Virtual Network Assurance API needs to be changed by updating HTTP to HTTPS and updating the port number. In the API URL, we'll change HTTP to HTTPS and change the port number to the default HTTPS port 8443. And we can see we have access to the API, so the HTTPS configuration is working. And because VNA is secured with CA signed certificates, we don't see a warning screen that the browser does not trust the certificate. Now that we know HTTPS is working, the final key step is to back up the Wildfly key store file, private key, and CA signed certificates to a secured storage location based on your organizational security policies. Next, we will demonstrate the process of creating a private key using the configure SSL VNA script. When we create the private key, the script will also secure VNA using self-signed certificates. Self-signed certificates are not inherently trusted because they were not issued by a trusted CA, and this can cause communication issues with DX NetOps components, so using self-signed certificates is not recommended. To resolve this issue, we will use the private key we generated to create a certificate signing request, or a CSR. The CSR is sent to a CA, and the CSR contains the private key we generated. The CA will use the private key to generate the CA signed, root, intermediate, and server certificates. The CA will not return a private key, as we provided the private key in the CSR. When the CA returns the certificates, we will import them into the system, replacing the self-signed certificates with the CA signed certificates. The CA signed certificates are inherently trusted by other components, so this will resolve any potential communication issues from the self-signed certificates. To generate the private key ourselves, we will perform the demonstration on a fresh install, on a new server, where HTTPS has not been configured at any time. To generate the key, we'll run the configure SSL VNA script. The script is located in the VNA install directory, in the tools, bin directory, and in order for the script to run properly, we need to be in this directory, so we will navigate to the directory first. And as a reminder, the configure SSL VNA script creates the key store in the Wildfly directory, and the script will not run if a key store already exists in the Wildfly directory. When we backed up the files earlier, we verified a key store did not exist, so the script should execute without issues. When we run the script, we need to include the password flag, so we'll enter the default password of change it, and run the script. At the prompt to start the import of a certificate, we will enter 1, to select the self-signed certificate option. And to clarify, the prompt says to import the certificate, but technically, the script will create the private key, the key store, and the complete self-signed certificate chain, then import the certificates, so there isn't an existing certificate that needs imported. We'll hit enter, and the next set of prompts will ask for information that will be used to create the certificates. For the first prompt, we need to specify the hostname or IP address the certificate will protect. This would be the hostname or the IP address of the VNA host server. If a hostname is used, it needs to be the fully qualified DNS name for the VNA host. For this demo, we'll enter the VNA hostname. Next, we'll enter the alias name for the certificate. The default is CA-VNA, but in an environment with multiple VNA hosts, the alias can be more descriptive to identify the host. For example, if this VNA server hosted a Viptela plugin, the alias could be VNA Viptela. Also, the alias does not have to be unique for each server, so the same alias can be used across all VNA servers. For this demo, we will press enter and accept the default CA-VNA alias. Next is the prompt to enter the name of your organizational unit. This is a Broadcom software demo, so we'll press enter to accept the default of Broadcom software. At the next prompt, enter the name of your organization. This is a Broadcom demo, so we'll press enter to accept the default value of Broadcom. The next set of prompts ask for geographic location information. These prompts are not required, and the default values of none can be used. For example, for the next prompt asking to enter the city where the organization is located, we'll press enter to accept the default value of none. For the next prompt asking for the state or province where the organization is located, we'll press enter to accept the default value of none. The next prompt asks for the 2-letter country code for the organizational unit. We'll press enter to accept the default value of none. So at this point in the script, the parameters entered in the prompts are displayed, and we can see in the message that the certificate was created with these parameters, and the import of the certificate is done. After the script imports the certificate, we need to select the TLS mode. We'll enter 1 for mixed mode. The mixed mode is the most flexible mode, but this can be changed later if needed, without having to re-import or update certificates or keys. If you are unsure which mode to select, check with your security team. At this phase, the script provides a note about TLS protocols and securing the communications between the VNA Wildfly application server and the VNA MySQL database. The Wildfly and MySQL components are hosted on the same server, so in most cases, this connection is not secured. So for the prompt asking if we would like to configure server certificate validation for the MySQL server, we will enter 1 to keep the secure communications disabled. But, if your organization requires securing connections between the components on the same host, reach out to support for assistance with this configuration. And after completing the MySQL prompt, the final configuration takes place, and Wildfly restarts to implement the security configurations. Then once Wildfly restarts, an info message displays, indicating that the configuration for VNA was successful. So at this point, the communications between the VNA server and the other DX NetOps components are secured with self-signed certificates. With HTTPS enabled, anyone accessing the DX NetOps Virtual Network Assurance API will need to use the HTTPS URL. However, because the certificate is self-signed, when the VNA server communicates with other secured components in the DX NetOps environment, the other components may not immediately trust the self-signed certificate from the VNA server, and this may cause communication issues between the components. For example, when the DX Virtual Network Assurance API is accessed, the browser may display a warning that it does not trust the self-signed certificate, and the user will need to manually tell the browser to trust the certificate before they can access the API. So for this reason, using a self-signed certificate is not recommended as a long-term solution. However, the private key, used to create the self-signed certificates, can be used to create and send a CSR to a certificate authority, requesting a CA-signed certificate chain for the VNA server, which will be immediately trusted by the other DX NetOps components, without any manual steps. To generate the CSR, we'll run the keytool utility, using the following flags. The cert request flag, to indicate we want to generate a CSR. The keystore flag, to define the directory and file name of the Wildfly keystore. The store pass flag, which is the password for the keystore. In this example, the default password is changeit. The extension flag, that generates a required X509v3 certificate extension. Next, we need to specify the subject alternative name, referred to as a SAN. To define the SAN, the DNS name for the virtual network assurance host is used, and the DNS name must be the fully qualified host name for the VNA server. For the alias flag, we'll specify the alias used in the self-signed certificate creation process, CA-VNA. And then finally, the file flag defines the path where the CSR should be saved, and the file name for the CSR. With the flags all filled out, we'll run the keytool utility. When the keytool runs, a warning displays, recommending migrating to PKCS12. This warning can be ignored. Now that the keytool utility finished creating the CSR, we'll navigate to the directory with the CSR, and open the CSR file. The next step is to copy the contents of the CSR, including the begin new certificate request line, and the end new certificate request line, then paste the contents into a CA request email, or submission form, depending on how the CA prefers to receive requests. We won't demonstrate this process, as it can vary across CAs. When the CA receives the request, the CA will use the private key in the CSR to generate the CA signed certificates. Then once we receive the CA signed certificates from the CA, we will import them into the VNA keystores to replace the self-signed certificates. So at this point in the demo, the CA returned a single PEM file with the host name of the VNA server, and we have broken out the files in the temp directory using the method we demonstrated earlier in the video. In the files, notice the CA only returned the certificates, and no private key, because we provided the CA with the private key. Also, keep in mind, these files are critical to the security of the system, so once the HTTPS configuration is done, the certificates should be moved to a secured backup location, and the files permanently deleted from the temp directory. For the next step of importing the certificates, we will use the keytool utility for each certificate. We won't run the configure SSL VNA script because a keystore already exists and the script won't run. We also don't want to delete the existing keystore because the keystore we created earlier contains the unique private key the CA used to sign the certificate chain. We'll run the keytool utility to import the CA-signed root certificate, which will replace the self-signed certificate. In the keytool command, the import cert flag indicates the tool will be used to import a certificate. The trust CA certs flag tells the utility that the certificate is from a CA and can be trusted. The keystore flag is the full path to the Java CA cert trust store, located in the Java install directory under the lib security folder. The store pass flag defines the password for the keystore, and will use the default password of changeit. The alias flag defines the alias for the certificate to import. When the CA created the root certificate, it gave the certificate the alias of root CA, so we will enter that for the alias. And for the file flag, we'll enter the path and file name of the root certificate for the key tool to import. We'll run the key tool utility, and at the prompt asking if we trust this certificate, we'll enter yes. And now we can see the certificate was added to the key store. Next, we need to use the key store tool to import the intermediate certificate. We'll run the key tool utility to import the intermediate certificate into the Java CA certs trust store. We'll use the same flags that we used to import the root certificate, but for the alias, we'll enter intermediate CA, and for the file, we'll enter the path and file name for the intermediate certificate file. We'll run the key tool utility, and we can see the process is finished, and a message indicating the certificate was added to the key store. And finally, we need to use the key store tool to import the server certificate. However, the server certificate needs to be imported into the Wildfly key store located in the VNA install directory, in the Wildfly standalone configuration directory. We'll use the same flags that we used to import the other certificates, but for the key store flag, we will enter the path to the Wildfly key store file. And then for the alias, we'll enter the CA VNA alias defined earlier. And for the file flag, we'll enter the path and file name for the server certificate file. We'll run the key tool utility, and we can see the process is finished, and a message indicating the certificate was added to the key store. VNA is now configured with HTTPS using CA signed certificates. At this point, to finalize the configuration, we'll restart Wildfly manually. And with Wildfly restarted, the configuration is complete. To test the HTTPS configuration, we'll access the DX Virtual Network Assurance API. In the API URL, we'll change HTTP to HTTPS, and change the port number to 8443. And we can see we have access to the API, so the HTTPS configuration is working, and because VNA is secured with CA signed certificates, we don't see a warning that the browser does not trust the certificate. Now that we know HTTPS is working, the final key step is to back up the Wildfly key store file and the CA signed certificates to a secured storage location, based on your organizational security policies, then permanently delete the files in the temp directory. This concludes the video. Configure HTTPS for virtual network assurance.